So, okay, good evening, everyone. My name is Chris Vidal Pereira from the MA 1A of Cavite State University Engineering Department. So, now we are going to tackle about analytic geometry. So first, we are going to find the distance between the points. So problem number 1 is at the 1, 5, and -5 and positive 3. So to find the distance between the 2 points, we're going to use the distance formula, which is d is equals to square root of quantity of x minus x sub 1 square plus quantity of y minus y sub 1 quantity squared. So after that, we're going to substitute this value to the variable. So d is equals to square root of quantity of 1 minus -5 squared plus 5 quantity of 5 minus 3 square, then it is equals to square root of 1 plus 5 square plus 5 minus 3 square. So equals to square root of 1 plus 5 is equals to 6, then square, then 5 minus 3 is equals to 2. So 6 times 6 is equals to 36, then 2 times 2 is equals to 4. So 36 plus 4 is equals to the square root of 40. Then to find, factor 40. So it is equals to the square root of 4 times 10. Then the square root of 4 is equals to 10. So the final answer is 2 the square root of 10. So number 2. So the given is -2 and -4. And the another one is y 1 and positive 6. -2 is the x sub 1 and positive 1 is the x sub 2. X sub 1, x sub 2, y sub 1, y sub 2. So in this problem, we're going also to find the distance. So d is equals to the square root of quantity x minus x sub 1 square plus quantity of y minus y sub 1 square. So the value of, then substitute the value of x, which is the -2, then the x sub 1 is positive 1. Then same also there, the value of y is equals to -4. Then the value of y sub 1 is positive, is equals to 6, then square. So -2 minus 1 is equals to -3 plus -4 minus 6 is equals to -10. So -3 square is equals to positive 9, then -10 square, -10 is to 2 is equals to 100. So the square root of 9 plus 100 is equals to the square root of 109. So the final answer, so the distance between the points is equals to square root of 109. So number 3, given is -3 and 4, and the other one is 3 and positive 6. So same as the problem in 1 and 2, we're going to also define the distance between points. So square root of x minus x sub 1 square plus y minus y sub 1 square. So the square root of the value of x is equal to negative 3 minus the value of x sub 1 is positive a is equals to 3. Then square plus the value of x of y is positive 4 minus the value of y sub 1 is equals to 6 square. So the square root of negative 3 minus 3 is equals to negative 6 square plus 4 minus 6 is equals to negative 2 square. So the square root of negative 6 square is 36 plus this negative 2 square is equals to 4. So the square root of 36 plus 4 is equals to the square root of 40. Then factor out also, it will become the square root of 4 times 10. So the square root of 4 is equals to 2. So that's why that's why the final answer is equals to 2, the square root of 10. So number 4. The given is 8, positive 8, and positive 1. The other one is 0 and negative 5. Then also, same as the problem 1, 2, and 3, we are also given, are also assigned to find the distance between points. So the formula of distance formula is equals to t, the square root of quantity of x minus x sub 1 square plus y minus y sub 1 square. So substitute the value of x and y will become quantity of 8 minus 0 square plus 1 minus negative 5 square. So it was to square root of 8 square plus 6 square. So 8 square is equals to 64, then 6 square is equals to 36. So 64 plus 36 is equals to the square root of 100. So square root of 100 is equals to positive 10. Number 5. So the given is 1 and 3 halves, then the other one is negative 7 and negative 5 halves. Find the distance between points. D is equals to the square root of quantity of x minus x sub 1 square plus y minus y sub 1 square. Then substitute the value is equal, then it is equals to square root of 1 minus negative 7 square plus 3 halves minus negative 5 halves square. So then it will become square root of 8 square because the 1 minus negative 7 is equals to positive 8. Then 3 halves minus negative 5 halves is equals to positive 4 square. Then 8 times 8, 8 square is equals to 64, then 4 square is equals to 16. So the square root of 64 plus 16 is square root of 80. Then factor 80, it will become 16 times 5. So the square root of 16 is 4. So the final answer is 4 square root of 5. Number 6. Negative 2 halves, then negative 3 over 24. Then the other one is 5 and negative 5 12. So also, same as the problem 1 to 5, we're going also to find the distance between points. So d is equals to square root of x minus x sub 1 square plus y minus y sub 1 square. So substitute the value, it will become square root of negative 2/3 minus 5 square plus negative 3/4 minus negative 5 over. Sorry for the type of that. It is 24, I think. Then negative 5/12 square. So it is equal to square root of negative 17 over 3 square plus negative 1/3 square, and it will become negative 289 over 9 plus 1 over 9. So the square root of negative 289 over 9 plus 1 over 9 is equals to 290 over 9. So the square. So the final answer is 1/3 over. I mean 1/3 the square of 290. Number 8. Show that the points negative 2 to 5, negative 2, negative 1, and 4, and negative 1 all lie on a circle whose center is at 1 and 2. Find the length of the ridges. So here is the graphing. So to find the radius, the formula is B is equals to same as the formula of distance formula. X is equals x minus x sub 1 square plus y minus y sub 1 square. Then after that, we are going to substitute the value of x and y. So b is equal to the square of negative 2 minus 1 square plus negative 1 minus 2 square. So d is equal to the square of negative 2 minus 1 is equal to negative 3 square plus negative 1 minus 2 is equal to negative 3 square. So d is equal to the square of negative 3 square is equal to 9. Then also here negative 3 square is equal to 9. So d is equal to square of 18. Then factor square of 18 will become 9. It will become the square of 9 times 2. So the square of 9 is 3. So the final answer or the length of a radius is 3 square of 2. So let's proceed to number 9. Show that the points 4 and 5, 1 and negative 1, and negative 2 and 5 are the vertices of an isosceles triangle. So find the area. Alright, here is the graphing. Here is the point negative 2 and positive 5 at the plane 1, and the positive 1 and negative 1 is here, and 4 positive 4 and 5 is at this point. So to find the distance between the point 4, 5 and 1 and negative 1, d is equal to the square root of 4 minus 1 square plus 5 minus 1 square. So d is equal to the square root of 3 square, the value of 4 minus 1, plus 4 square, the value of 5 minus 1 square. So d is equal to 2 square root of 9 plus 16. Okay. D is equal to the square root of 25, value of 9 plus 16. So the square root of 25 is equal to 5. So also here we're going to find the value of a point 4 and 5 and negative 2 and 5. So to solve, d is equal to the square root of 4 minus negative 2 square plus 5 minus 5 square. So d is equal to 6 square. 4 minus negative 2 is equal to positive 6. Then 5 minus 5 is equal to 0. So we're going to cancel out. So d is equals to the square root of 36, which is the 6 square. Then the square root of 36 is positive 6. So 6 over 2 is equals to 3. To find the area, we are able to use the Pythagorean theorem, which is c squared is equals to a squared plus b squared. So c squared is equals to 5. So 5 squared equals to the value of a squared, which is here 3, plus the b is the unknown. So 5 squared is 25, equal to 3 squared is 9 plus b squared. So b squared is equals to 25 minus 9. You are curious why this formula come up. So here it is. So b squared transpose to the here, then so that the formula becomes b squared is equals to 25 minus 9. Or let's say we are transposed positive 9 to this side. That is why that becomes negative. So b squared is equals to 16 because 25 minus 9 is equals to 16. Then square b squared minus 16. So it will become positive 4. So the value of b is positive 4. So now we gather the value of b and the h, and so for the final, we are now able to use the formula, the area formula, to find the vertices of an isosceles triangle. So the formula of area is equals to A. The formula of area is A is equals to BH over 2. So A is equals to B, which is positive 6, then H is positive 4. So sorry, I tried to for the typographical error na naman. So then over 2. So 6 times 4 is 4. So sorry, this is 4. 6 times 4 is 24 over 2. So the area of an isosceles triangle is 12 square units. So number 10, show that the points negative 1 and negative 2, positive 2 and 1, and negative 3, and 6 are the vertices of a right triangle. So find the area. So here, first we're going to find the area in point 2, 1, negative 3, and 6. So here, d is equals to square root of 2 minus negative 3 square plus 6 minus 1 square. So d is equals to 5 square. 5 is, so d is equals to the square root of negative 5 square plus negative 5 square. So d is equals to square root of 25 plus 25. So d is equals to the square root of 50. Then after 50 will become the square root of 25 times 2. So the final answer is d is equals to 5 square root of 2. Then for the second one, we're going to find also the point between the vertices. Between the point 2, 1, negative 1, and negative 2. So here is the formula. D is equals to the square quantity of 2 minus negative 1 square plus quantity of 1 minus negative 2 square. So D is equals to the square root of quantity 3 square plus quantity 3 square. So D is equals to square root of 9 plus 9. So D is equals to the square root of 18. Then factor square root of 18 will become square root of 9 times 2. So the square root of 9 is equals to 3. So the final answer is 3 the square root of 2. So to find the area of the right triangle, we are going also to use the formula of area, which is A is equals to BH over 2. Then A is equals to 5. Substitute the value of B, the B, and the value of H. So here it is. A is equals to quantity of 5 square root of 2 times 3 the square root of 2 over 2. So it will become A is equals to 15. 5 times 3 is equals to 15. And square root of 2 times square root of 2 is square root of 4. Then A is equals to 15 times 2. Square root of 4 is equals to positive 2 over 2. So A is equals to 30 over 2. So the area of a right triangle is equals to 15 square units. Number 14. Find the area of the quadrilateral having the points negative 3 and 4, negative 2 and negative 1, 4 and 4, and 0 and 5 as vertices. So point A is at negative 3 and positive 4, and point B is negative 2 and negative 1, and point C is 4 and 4, and D is 0 and 5. The illustrations for the diagonal. Sorry. So the diagonal going downward, here, negative 3 times negative 1 is positive 3, negative 2 times positive 4 is negative 8, then 4 times 5 is positive 20, 0 times 4 is 0. So 3 minus 8 plus 20 plus 0 is equals to 15. So the diagonal going there, 4 times negative 2 is negative 8 here, then equals to negative 40 minus 5, then it equals to negative 27. So the diagonals or the answers for the area of the quadrilateral is equals to 21 square units. Number 17. Find the radius of a circle with a center at 4 and 1 if a chord the length of 4 square root 2 is bisected at point 7 and 4. So we're going to find at point 4 and 1 and point 7 and 4. So we're going to solve the distance of this point. So d is equals to square root of positive 7 minus 4 squared plus positive of 4 minus 1 squared. So d is equals to square root of positive 3 square plus positive 3 square. So d is equals to square root of 9 plus 9. Then d is equals to square root of 810. Also, we're going to factor square root of 810. It will become square root of 9 times 2. So square root of 9 times 2 is 3 square root of 2. Then we use Pythagorean theorem to find the radius of a circle. So c square is equals to 23 square root of 2 square plus 4 square of 2 over 2 square. So c square is equals to 18 plus 32 over 4. C square is equals to 18 plus 32 over 4 is equals to 8. Then c square is equals to 26. So we are going to square both sides. So the final answer is c is equals to final answer is c is equals to the square root of 26. So the radius of a circle with the center 4 and 1 is square root of 26 over 18. So the radius of a circle is 5 at its center is at 3, negative 3, and negative 4. So find the length of the chord that is bisected at negative 11 over 2 and negative 13 over 2. So we're going first to find the distance of point negative 3 and negative 4 and negative 11 over 2 and negative 13 over 2. So d is equals to square root of quantity negative 3 plus 11 over 2. You're wondering why it will become positive because negative times negative is equals to positive. Plus negative 4 plus 13 over 2 square. So d is equals to positive 5 halves square plus 5 halves square. So d is equals to 25 over 4 plus 35 over 4. So d is equals to the square root of 50 over 4. So first we are going to factor 50. So it will become the square root of 25 times 2 over 4. So the answer is 5 square over 4. So same as the previous number, we're now going to use Pythagorean theorem. Substitute the value of c, which is 5 is equal 5 equals to the value of a squared, which is 5 square root of 2 over 2. Then become, square plus b square. So 5 square is equal to 35 equal to 35. Then 5 square root of 2 over 2 square is equals to 50 over 4. Then copy b squared. So transpose 5 over 4. So b squared is equals to 50 over 4. Then square both sides. Squaring both sides, it will become b is equals to square root of 50 over 4. So the the value of b is equals to 5 square root of 2 over 4. So the chord, the length of a chord that is bisected at negative 11 over 2 and negative 13 over 2 is 5 halves, is at 5 halves, 5 square root of 2 units. Let's proceed to number 19. So find the area of the polygon whose vertices are 0.1, negative 4, 4, negative 1, and 4 and 5, negative 1, 4, and negative 2, and at negative 1. Here, I draw here the polygon with its respective points. That I solve the area of 6 times 3 over 2 equals to 18 over 2. So the area of point is 9 square units. So same as here. So to find the distance of point negative 1 and positive 4 and positive 4 and positive 5 point is b is equals to square root of positive 4 minus negative 1 square plus 5 minus 4 square. B is equals to square root of 4 plus 1 square plus 5 minus 4 square. So b is equals to square root of 5 square plus 1 square. So b is equals to 25 plus 1. So 25 plus 1 is equals to the square root of 26. So same as here at point negative 4, negative 1, and 4, 4, and 5. So b is equals to positive 4 minus negative 2 square plus 5 minus negative 1 square. So d is equals to square root of 4 plus 2 square plus positive 5 plus 1 square. So d is equal to square root of 6 square plus 6 square. So d is equals to the square root of 36 plus 36. So square root of 36 plus 36 is equals to square root of 72. Then factor square root of 72 will become to square root of 36 times 2. Then the square root of 36 times 2 is 6, the square root of 2. So to find the area of the polygon, we are going to use again the Pythagorean theory. Substitute the value of its respective variables, the a, b, and c. So the value of c is square root of 26, same as the value of a. The value of a is equals to 6, the square root of 2 over 2 square plus b square, which is unknown. So the square root of 26 square is equals to 26, then equal to the value of 6 square root of 2 over 2 square is 72 over 4 plus copy b square. So transpose 72 over 4. So it will become b square is equals to 32 over 4. So 32 over 4 is equals to 8. So squaring both sides, the value of b is equals to square root of 8. Then after that, factor square root of 8 will become the square root of 4 times 2. So the square root of 4 times 2 is equals to 2, the square root of 2. So when the area of the polygon here, here is the formula. So A is equals to the value of value of A times the value of H, which is here, to the square root of 2 over 2. So 6 square root of 2 times 2 square root of 2 over 2 is equals to 12 square root of 4 over 2. Then square root of 4 is equals to 2. So 12 times 2 is equals to 24 over 2. So 24 over 2 is equals to 12. So the area of a polygon whose vertices are 1 and negative 4, 4 and negative 1, 4 and 5, negative 1 and 4, and at point negative 2 and negative 1 is 12 square units. So number 21, find the point on the y-axis that is equidistant from 5 from point 5 and 1 and point negative 3 and negative 1. Here is the illustrations. The solutions. Quantity of 0 minus 5 square plus quantity of y minus 1 square is equals to quantity of 0 plus 3 square plus y plus quantity of y plus 1 square. So 0 minus 5 is 5. So 5 square is 25 plus y square minus 2y plus 1 equals to 0 plus 3 is equals to 3. So 3 square is equals to 9. Then expand y square plus 2y plus 1. So combine like terms. Y square minus y square minus 2y minus 2y plus 1 minus 10 plus 25 is equals to 0. Cancelled out, cancelled out. And negative 2y minus 2y is equals to negative 4y plus 1 minus 10 plus 25 is equals to 16 equals 0. So for y, so 16, transpose 16 to going there. So it will become negative 4y is equals to negative 16. Then divide both sides by 4. So it will cancel. So the final answer is equals to, so the y-axis is equals to 4. Number 22. So a line segment 5 units long has one of its end at point 3, 1. The ordinate of the other end is 5. So find the abscissa. 5 is equals to the square root of 3, which is the value of x of 1, minus x squared plus the value of y sub 1, then the value of y sub 2, which is 1 minus 5 squared. So 5 minus is equals to square root of 3 minus x squared plus 1 minus 5 is equals to negative 4 squared. Then multiply both sides by 2. So the squared sign will be cancelled out. So 5 squared is equals to 25. Then equals to quantity of 3 minus x squared plus negative 4 squared is 16. So 25 equals to 9 minus 6x plus x squared plus 16. Then transpose. So 25 minus 9 minus 16 is equals to 0. So it will become x squared minus 6x equals to 0. Then factor x squared minus 6x will become x times the factor of x minus 6 equals to 0. So the value of x is equals to 0 and 6. So the abscissa is at 0 and 6. Number 24. The point x in 1 is 2 square root of 5 units from point 2 and 3. So find x. So our d here is 2x squared of 5. So the formula is 2 squared of 5 is equal to square root of 2 minus x squared plus 3 minus 1 squared. Then multiply both sides by 2. So it will become 4 times 5 equals to the quantity of 2 minus x squared plus 3 minus 1 squared. So 4 times 5 equals to x squared minus 4x plus 4 plus 3 minus 1 is 2 squared. So for this 5 is 20, then equals to x squared minus 4x plus 4, then 2 squared is equals to 4. So 20 is equals to x squared minus 4x. 4 plus 4 is 8. So transpose 20. So that will become negative 20. So 0 is equals to x squared minus 4x plus 8 minus 20. So 0 is equals to x squared minus 4x minus 12, which is the value of 8 minus 20. So 0 is equals to x squared plus sorry. After this, we are also to find the difference. Find the difference of negative 4x. So that is positive 2 and negative 6. So 0 is equals to x squared plus 2x minus 6x copy negative 12. So 0 is equals to x times quantity of x plus 2, then minus 6 rather. 6 times x plus 2. So x plus 2 times x minus 6 is equals to 0. So x plus 2 is equals to 0. X minus 6 is equals to 0. So the value of x is at 2 and positive negative 6. Sorry. Number 25. What are the coordinates of the points? 3 units from the y-axis and a distance square root of 5 from point 5 and 3. So square root of 5 equal to square root of 3 minus 1 square plus 5 minus 3 square. Then multiply both sides by 2. So that's why the square is the square sign is cancelled. So it will become 5 minus quantity of 3 minus y squared plus 5 minus 3 squared. So 5 copy 5, then equal to y squared minus 6y plus 9. Then 5 minus 3 is equals to 2 squared. Copy 5, equal to y square minus 6y plus 9. So 2 square is equals to 4. P5 equal to y square minus 6y. Then 9 plus 4 is equals to 13. So 0. So 5 transposed to this side will become 5. So 0 is equals to y square minus 6y plus 13 minus 5. So 0 is equals to y square minus 6y plus 8. So factored. So quantity of y minus 4 times quantity of y minus 2 is equals to 0. So the value of y is 4 and 2. Number 26. A point whose abscissa and ordinate are equal is square root of 10. Unit from negative 1 and negative 3. So find the point. So the d here is equals to, the value of d here is equals to square root of 10. So substitute. So square root of 10 is equals to square root of x minus negative 1 square plus x minus negative 3 square. And multiply both sides by 2. So this square sign is cancelled. So negative 10 is equals to the quantity of x plus 1 square plus x plus 3 square. So 10 is equals to x square plus 2x plus 1 plus x square plus 6x plus 9. So transposed 10 to this side. So they'll become 0 equals to 2x square plus 8x plus 10 minus 10. So 0 is equals to 2x square plus 8. So 10 minus 10 is equals to 0. So divide. So divide both sides by 2. This is 2. Sorry. By rather 0 is equals to 2x squared plus 8x over 4. So it will become 0 x squared plus 4x. So x plus 4 is equals to negative. So the value of x is equals to negative 4 and at the side is 0. So number 27, the ordinate of a point which is square root of 29 units from 5.5 and 1 is twice its abscissa. Find the point. So the formula is distance formula. So using distance formula again. So the value of x sub 1 is 5, x sub 2 is x, y sub 1 is positive 1, and y sub 2 is 2x. So the value of p is square root of 39. Substitute the value of the respective variable. Square root of 29 is equal to square root of x minus 5 square plus 2x minus 1 square. Then multiply both sides by 2. So the radical sign or the squared sign is cancelled. So that it is equals to quantity of x minus 5 square plus 2x minus 1 square. So 39 is equal to x square minus 10x plus 25 plus 4x square minus 4 plus 1. So transpose 29 to the side. So it will become 0 is equals to 5x squared minus 14x plus 26 minus 29. So 0 is equals to 5x squared minus 14 minus 3. So 5x plus 1 times x minus 3. So x is equals to negative 1/5. So x equals to 2x. So y sub 2 is equals to 2x. Then substitute the value of x, which is negative 1/5. So it will become 2 times negative 1/5. So y is equals to negative 2 over 5. Then on the side, the value of x is equals to positive 3. So again, same as here, we're going to substitute the value of x. So the formula is y equals to 2x. So the value of x is equals to 3. So 2 times 3 is equals to 6. So the point is negative 2 and positive 6. We'll proceed to number 10a. So the abscissa of a point is 2/5 of its ordinate. So find the point if it is 5 units from negative 2 and 2. So d is equals to 5. The x sub 1 is equals to negative 2. X sub 2 is 2 over 5x. Y sub 1 is equals to 2. Then y sub 2 is equals to y. So formula is d is equal to square root of x sub 2 minus x sub 1 square plus y sub 2 minus y sub 1 square. Substitute the value. So 5 is equal to square root of 2/5 y minus negative 2 square plus y minus 2 square. Then multiply both by 2, so it becomes 25. 25 equal to 2 over 5y plus 2 square plus y minus 2 square. So 35 equals to 30 over 25y square minus 12 over 5y plus 8 minus 25. So 0 is equals to 29 over 25y square minus 12 minus 5y minus 17. So quantity of 29 plus 85, 9y minus 5. So y is equals to negative 85 over 29. Y is equals to, so here the value of x squared here is 2 over y, 2 over 5y mean. So let's substitute the value of y, it is negative 85 over 29. So the formula is 2 over 5 times 85 over 29. So y is x is equals to negative 34 over 29. Same as here, the value of y is equals to positive 5. So x is equals to 35 over 5y. Substitute the value of y, which is 5. So 2/5 times 5 is equals to 10 over 5. So 10 over 5 is equals to 2. So the point is at negative 334 over 9 and positive 2. Number 29. So the abscissa and ordinate of a point 2 square root of 5 units from point 3 and positive 3 and positive 3 are numerically equal but of opposite sign. Find the point. So find the point. So 2 square root of 5 is equals to square root of 3 plus x squared plus 3 minus x squared. So both set by 2. So that's why the radical sign cuts out. So 4 times 5 is equals to 3 plus x squared plus 3 minus x squared. So 4 times 5 is equals to x squared plus 6x plus 9 plus x squared minus 6x plus 9. So 4 times 5 is 20 equals to 2x squared. Combine the like terms equals to 2x squared plus 18. Then divide both sides by 2. So it equals to 10x squared plus 9. Then transpose 10 to this side. So it will become x squared equal to 10 minus 1, then x squared is equals to positive 1, then squaring both sides. So the answer, so the point x is at negative 1 and positive 1. Number 3, the abscissa of a point in the fourth quadrant is numerically 3 times its unit, and it's 10 units from negative 2 and 4. So find the point. So the d here is positive 10. Then x sub 1 here is negative 2. X sub 2 is x. Y sub 1 is 4. And y sub 2 is negative 1/3 x. So substitute. So 10 is equals to square root of x minus negative 2 square plus negative 1/3 x minus 4 square. So apply both sides. Equal to 100 equals to quantity of x plus 2 square plus 1/3 x minus 4 squared. So 100 is equals to x squared plus 4x plus 4 plus 19x squared plus 8 over 3x plus 14. So 100 is equals to 10 over 9x squared plus 20 over 3x plus 20. So 0 is equals to 10 over 9x squared plus 20 over 3x plus 20 transpose 100. So to become negative 100. So 0 is equals to 10 over 9x squared plus 20 over 3x minus 80. So x plus 12 and x minus 6. So the value of x is negative 12 and the other one is positive 6. So our given here is the value of x sub 2 here is negative 1/3 x, and substitute the value of x. Let's try the positive x rather. So y is equals to negative 1/3 times the value of x, which is positive 6. So y will become negative 2. So the point is at negative 2. Number 31. Expressed by an algebraic equation, the statement that the point x and y is equidistant from 6 and negative 2 and 5 and negative 2. So given is y sub 1 is equals to 6, y sub 2 is equals to 5. I mean x sub 2 is equals to 5, x sub 3 is equals to x. Then y sub 1 is equals to negative 2, y sub 2 is positive 2, then y sub 3 is equals to y. So we're going to use p sub 1 is equals to p sub 1. So here it is square root of x sub 3 minus x sub 2 square plus y sub 3 minus y sub 2 square equal to square root of x sub 3 minus x sub 1 square plus x sub 3 minus x sub 1 square. So multiply both sides. I know rather substitute the value square root of x minus 5 square plus y minus 2 square equal to square root of x minus 6 square plus y minus negative 2 square. Then multiply both by 2. So the radical sign multiply itself. So x minus 5 square plus y minus 2 square is equals to x minus 6 square plus y plus 2 square. So x square plus x squared plus 10x plus 35 plus y squared minus 4y plus 4 equal to x squared minus 12x plus 36 plus y squared plus 24y plus 4. So combine like terms, x squared minus x squared plus y squared minus y squared minus 10x plus 12 minus 4x minus 4y equals to 40 minus 29. So x squared minus x squared will be cancelled out, same as y squared minus y squared. So 10x plus 12x, negative 10x plus 12x is equals to 2x, then negative 4y minus 4y is equals to negative y. So it will become 2x minus 8y, and the value of 4 minus 29 is 11. So the equidistance, equidistant from 6 and negative 2 and 5 and 2 is 2x minus 8y is equals to 11. So here is the final answer. So let's proceed to number 32. Expressed by analogical equations, the statement that the point x and y is at distance 3 from negative 7 and then 3. Yeah. So the value of d is equal to 3. So x of 1 is equal to negative 7. X of 2 is x. X of 1 is negative 3. X of 2 is 5. So d is equal to the square root of x sub 2 minus x sub 1 square plus y sub 2 minus y sub 1 square. Substitute the value. So 3 is equal to the square root of x minus negative 7 square plus y plus 3 square. And multiply both sides by 2. So it will become 9 equals to x plus 7 square plus y plus 3 square. So 9 is equal to x square plus 14x plus 49 as y square plus 6y plus 9. So transpose 9 to the left side. So the factor 0 equals to x squared plus 14x plus 49 plus y squared plus 6y plus 49 plus 9 minus 9. So 0 is equal to x squared plus y squared plus 14x plus 6y plus 49, or x squared minus y squared plus 14x plus 6y plus 49 is equals to 0. Number 33. So find the coordinates of the point equidistant from 1, negative 6, and 5, and negative 6, and 6, and negative 1. So square root of x sub 4 minus x sub 1 square plus y sub 4 minus y sub 1 square equals to x square root of x sub 4 minus x sub 2 square plus y sub 4 minus y sub 2 square. Substitute the value. So x square root of x minus 1 square plus y minus negative 6 square equals to square root of x minus 5 square plus y minus negative 6 square. Then multiply both sides by 2. So medical side will be cancelled. So it will become x minus 1 square plus y plus 6 square equals to x minus 5 square plus 6 plus y minus plus 6 square. So x square minus 2x plus 1 plus y square plus 12y minus plus 36 equals to x square minus 10x plus 25 plus y square plus 12y plus 36, and combine like terms. X square minus x squared plus y squared minus y squared minus 2x plus 10x plus 12y minus 12y is equals to negative 37 plus 61. So the answer is x 8x is equals to 24. Then divide both sides by 8. So x is equals to positive 3. Same as here. Substitute the value. Square root of x sub 4 minus x sub 2 square plus y sub 4 minus y sub 2 square equals to square root of x sub 4 minus x sub 3 square plus y sub 4 minus y sub 3 square. So substitute the value of the formula. So square root of x minus 5 square plus 5 minus negative 6 square is equals to square root of x minus 6 square plus y minus negative 1 square. Then multiply both sides by 2 to become 3 minus 5 square plus 5 plus 6 square equals to 3 6 square plus of y plus 1 square. So 4 plus y square plus 6y plus 36 equals to 9 plus 5 square plus 2y plus 1. Y square plus 12y plus 40 is equals to y square plus 2y plus 10. Then combine like terms. Y square minus y square plus 12y minus 2y is equals to 10 minus 40. So 10y is equals to negative 40. Then divide both sides by 10. So y is equals to negative 3. Proceed to number 34. So a point is equidistant from negative 2 and positive 4 and 3 and 5. It is also equidistant from negative 2 and negative 3 and 6 and negative 1. So x sub n, the formula of x sub n is equal to 1/2 times x sub 4 plus x sub 3. So equals to y 1/2 times 6 minus 2. So 1/2 times 4 is equals to 4/2. So xm is equals to positive 2. And solve for y sub m. Same as the formula of x sub m. So 1/2 times negative 1 minus 3 is equals to 1/2 times negative 4. So 1/2 times negative 4 is equals to negative 4 over 2. So y sub m is equals to negative 2. Then the value of the x sub n and y sub m is substitute to these equations. So y minus negative 2 is equals to negative 4. This is the value of m n. So negative x minus 2. So y plus 2 is equals to negative 4x plus 8. So 4x plus y is equals to 6. So y is equal to 6 minus 4x. So y sub y is equal to y sub 2. So negative 7 minus 5x equals to 6 minus 4x. So negative 5x plus 4x equals to 6 minus 7. So negative, so the answer is negative x is equals to negative 1. Then divide both by negative 1, so x is equals to positive 1. Then also as here, y minus 7 minus 5x. So y is equals to 7 minus 5. Substitute the value of x, which is positive 1. So y is equals to 7 minus 5. So 7 minus 5 is equals to positive 2. So the value of y is positive 2. So the point is at positive 1 and positive 2. Find number 35. Find the point equidistant from negative 6 and negative 1 and negative 2 and positive 2 and at the distance from negative 2 and 7. Y sub m is equals to 1/2 times x sub 1 plus x sub 2. So 1/2 times negative 1 minus 6 x sub m is equals to negative 7 over 2. So y sub m equals to 1 half times x y sub 1 minus plus y sub 2. So 1 half times negative 1 plus 2. So y sub m is equals to 1 half. So these, to find the distance, we're going to use the distance formula. So this equals to x sub 4 minus x sub 3, x sub 1 minus x sub 2 plus x sub y sub 1 minus y sub 2. So then substitute the value. The value of d is equals to 5. So 5 squared is equals to square root of x minus negative 3 square plus y minus 7 squared. So 5 raised to 4, then multiply both by 2. So 5 raised to 4 is equals to 5 times x plus 2 square, then 5 square times y minus 7 square. So 5 raised to 4 is equal to 625, equal to 5x plus 10 square plus 25 times the quantity of y minus 7 square. So 625 is equal to negative 16 minus 3y plus 10 square plus 25, copy 25 times the quantity of y square minus 14y plus 49. So 625 equals to negative 3 minus 6y plus 25, copy y square minus 14y plus 49. So 625 equals to 9 square plus 36 y plus 36 plus 25 y square minus 350 y plus 1435. Then transpose 625 to left, excuse me. So it will become 0 equal to 84y square minus 314y plus 1261 minus 625. So 0 is equal to 84 y square minus 314y plus 636. Then divide both sides by 2, become 0 is equals to 17 y square minus 157x plus 38. So 5 minus 3 times 17 minus 106. So the value of y is equals to positive 3, and the other one is 106 over 17. So to solve at y is equals to 3, so y x is equals to 1/5 times 16 minus 3y, x equals to 1/5 times negative 6 minus 3 plus times the value of y, which is 3. So x equals to 1/5 times negative 6 minus 9. So x equals to 1/5 times negative 25. So x is equals to negative 20. Negative 5. So at 106 over 17. So y is equals to 1/5 times negative 16 minus 3 y, and substitute the value of y, which is 106 over 17. So 1/5 times negative 16 minus 3 times 106 over 17. So 1/5 times negative 6 minus 318 over 17. So 1/5 times negative 590 over 17. So y is equals to negative 118 over 17. Number 36. A point is at distance 4 square root 2 from point negative 2, negative 3 over 2, and negative 5 over 2. And at the distance of 2 square root of 5 from 9 halves and negative 5 halves, find the point. So d is equals to square root of x sub 3 minus x sub 1 square plus y sub 3 minus y sub 1 square. So substitute the value which is listed above. So 4 square root of 2 is equal to square root of 4. Square root of x minus negative 3 half square plus y minus negative 5 half square. So 32 is equal to 3 plus 3 half square plus y plus 5 half square. Then the other one is the distance 2 square root of 5. So 2 square root of 5 is equal to square root of x minus 9 halves square plus y minus negative 5 half square. So negative 2 square root of 5 square is equals to 20. Then equals to x minus 9 half square plus y plus 5 half square. Then subtract the value of this and this formula. So 32 is equals to x plus 3 half square plus y plus 3 half square minus 20 is equals to x minus 9 half square plus y plus 5 square, 5 half square. So it will become 12 is equals to a quantity of x plus 3 half square plus this quantity of x minus negative 9 half square. So 32 is equals to x plus 3 half square plus the quantity of x of y minus of y plus 5 half square. So 32 is equals to 5 halves square plus 3 half square plus the quantity of y plus 5 half square. So 32 is equals to 4 square plus y square plus 5y plus 25 over 4. So 0 is equals to y squared plus 5y plus 89 over 4 minus 32. So y squared plus 5y minus 39 over 4 is equals to 0. So y plus 13 halves times y minus 3 halves. So y is equals to the value of y. Sub 1 is negative 13 over 2. The other one is positive 3 halves. Here naman the other equations, 12 is equals to 3 plus 3 halves square minus x minus the value of x minus 9 halves square. So 12 is equals to x squared plus 3x plus 9 over 4 minus x squared minus 9x plus 81 over 4. Then multiply 4 both sides, so it will become 48 minus 4x squared plus 12x plus 9 minus 4x squared plus 36x minus 81. So 48 plus 72 is equals to 48x. So 120 is equals to 48x. Then divide both sides by 48. So x is equals to 5 halves. Number 7 is the last one. Find the coordinates of a point equidistant from negative 2 and 8, 1 and negative 1, and negative 8 and negative 4. So x sub 1 is equals to negative 2, y sub 1 is equals to positive 8, x sub 2 is equals to negative 8, y sub 2 is equals to negative 4. To solve the x sub m is equals to 1/2 times x sub 1 plus x sub 2. So 1/2 is equal to negative 2 minus 8, 1/2 times x negative 2 minus 8 is negative 10. So 1/2 times negative 10 is equals to negative 10 over 2. So x sub m is equals to negative 5. Then solve for y sub m. Y sub m is equals to y squared times 1 y sub 1 plus y sub 2. Then substitute the value. So y sub y 1/2 times 8 minus 4. Then 1/2 times 4 is equals to 4 halves. So y sub m is positive 2. Then last one is 38, which is the find the point whose distance from 7 and -3 is square root of 58 and whose abscissa equals its coordinates. So b here is equals to the square root of 58. Then x sub 1 is equals to 7, x sub 2 is x, y sub 1 is equals to -3, and y sub 2 is equals to x. So distance formula is b is equals to square root of quantity x sub 2 minus x sub 1 square plus the quantity of x of y sub 2 minus y sub 1 square. Then substitute the value. So square root of 51 is equals to square root of quantity x minus 7 square plus quantity x minus -3 square. So then after that, multiply both sides by 2, then theoretical sign will be cancelled. So 58 is equals to quantity x minus 7 square plus quantity x plus 3 square. So 58 is equals to x square minus 14x plus 49 plus x square plus x plus 9. Then transpose 58. So it will become 0 is equals to 2x square minus 8x plus 58 minus 58. So 0 is equals to 2x square minus 8x. Then divide both sides by 2. So 0 is equals to x squared minus 4. Then factor x squared minus 4 is x minus 4 times x minus 0. So x is equals to 4. So the other one is x is equals to 0. So the point is at 4 and 0. That's all. So thank you for listening.